Good morning. It's December 16th, 2023, and here from Seattle, Washington, USA. It's another talk in descriptive differential dynamics. Ross Finlayson here. Hopefully, you've had a chance to review some of the earlier content of this discussion, or monologue, as it were. But it's a discussion of the canon and our consciousness and our conscience and our conduct as conscientious logicians, conscientious mathematicians, and this kind of thing. Well, what I hope today was discuss just a little bit more from the beginning of differential analysis. And so, what is the instantaneous rate of change? What is y equals mx plus b, the equation of a line in slope-intercept form? M is the slope and b is the intercept of a line drawn in the xy plane. And then, as with respect to tangent and the notions from geometry, when things are incident but do not cross, the tangency of things, vis-a-vis those that are incident and actually cross, which basically indicates some affine translation for two lines of the orthogonal. And with regards to how triangles have 180 degrees or pi radians, and all such larger polygons have two, and the circle has two pi radians, and these kinds of things in terms of the sum of their inner angles. And then as with regards to how that's defined in terms of a circle or not, and this kind of thing. So what I've been trying to get to, and that I haven't really at all, is to walk through a sort of development as follows from the parametric form of a line, and then how we get into rise over run. Because before you really have to worry about the instantaneous rate of change, you can figure out the rate of change is that it's a rise over run. And so, of course, this must be one of the most absolutely familiar concepts to anybody who's ever taken a course that involved any kind of introduction and approach to dynamical modeling, is what is for a straight line and for a constant rate of change, what is the same as its instantaneous rate of change. That then, when I want to try and figure out how to relate that to, and again, these notions I haven't really spent too much time wondering about, are the stop derivative, which is kind of this great concept of a reflection on all the higher orders of acceleration and meeting and parting and starting and stopping in terms of relative motion and absolute rest, in a sense. With regards to relative rest and absolute motion. That these are the kinds of concepts that we parameterize, we formulaically symbolize, we make algebraic, and we make as quantities, then we make for the arithmetic, we make as quantities that result then, it's the matters of fact of all the things that add together in the universe, how they are and what they may be. So I collected some books here, and I wasn't quite sure how they're going to reflect too much in the stack of a brief introduction to the intermediate value theorem and the fundamental theorems of calculus. After you have the intermediate value theorem for continuous domains, according to laws of arithmetic and inequalities, that with regards to delta-epsilonics, the great little assemblage of proofs that shows via induction that for a given small thing, there's a smaller, and that we can get the notion of the definition of the limit formalized, vis-a-vis that it's been the same kind of thing since the antiquarians in the time of Zeno in the Eleatics, and Zeno of Elea, and the paradoxes of Zeno that are really thought experiments to be solved to help explain why there's the infinitely divisible and continuous uniform motion about Achilles and the tortoise who race. And then it's funny for the linear and rotational in physics to figure out whether they're on a straight track or a round track. And then there's the arrow, which is the notion that an arrow is launched from a bow, and when it starts and where it stops and as matters like how can it ever start, how can it ever stop, how can it ever depart, and how does it ever arrive. When, if you break it down in a case via simple induction, it's like, well, it never gets halfway, it never gets halfway, it never gets halfway, it never gets anywhere. But it does, so obviously that course of induction is has reached an impasse. It's an impassable thing for it to otherwise say anything at all. And so the idea then that Zeno's paradox of motion should be familiar to everybody as then what gets into delta-epsilonics, and then not ignoring the one and getting into the other as all there is, but just supplementing, adding to the context, so that then it's understood that the linear development, the linear curriculum, and the ordinary development, the standard development, is well-founded in the sense for what stipulations it makes, and for that it fits in the framework then of these other properties of the numbers that are already established, like trichotomy and the continuous divisibility of numbers, that they go then without saying for the rest of the thing, that is still framed in the properties of those that exist, that those have to also exist via some deduction, an abstraction, an abduction, deduction, a theory of these objects of the models of thought, which here are members of a strong mathematical Platonist universe of objects of mathematical thought and reasoning. Let's take a look at the stack today. Sidgwick's Ethics. So Sidgwick was a guy, he wrote this panoply, a coverage of all kinds of ethics. Sidgwick, Henry Sidgwick. The nucleus of this little book is formed by an article on ethics, which I wrote some years ago for the Encyclopedia Britannica. Wow. I found that in the opinion of persons whose judgment had weight with me, this article appeared likely to meet the needs of English students desirous of obtaining a general knowledge of the history of ethical thought. So in philosophy, as I kind of have talked about a little bit before, there's technical philosophy, objects of reason, and thought, and how there can be any at all. And then there's philosophy of all such matters as decision-making and psychology, the philosophy of psychology and the psychology of philosophy. And then they there's the two general notions of matters of conduct are ethics and morals. So the morals and mores reflect kind of like people have morals and the society has mores, or along these lines. And then the ethics are with regards to a little bit more detached rules of those. So the morals are kind of held to be very close to especially the tempestuous feelings, or like, love and hate and these opposites and this kind of thing. And as well, what's good and bad, or good and evil. Yeah. And ethics is kind of similar in that it does have this notion of what's good and virtuous in ethics, and in large part that's based upon the golden rule, egalitarianism and this and that. And of course that then when you consider any two bodies, or any two persons, or any two bodies of people, or any two mobs, and archaeology being the science of the mob, their psychology, and as well into things like tragedy of the commons and this and that, that the ethics are in a sense declaratory in terms of what are reasons for things that can be so cited and declared to be conscientious to have as a science of them, but also as so supports the conscience, whose role as an element of the subconscious is to provide a better angel, as it were, or the role of the conscience is to both affirm and reject decisions otherwise in the ethical and moral. That the conscientious mathematical logician is basically entirely mathematical and entirely logical and fair. With the truth that it boils down to being a philosophy of truth. Vis-a-vis that in our human milieu, in our human world, in our human condition, there are feelings, there are emotions, and all these kinds of things that arises from the subconscious, the id, superego, and ego, and then how does it come together? That ethics and morals guide this, and then also that it's usually strongly attached with the higher order in terms of systems of governance, or the deity, or the highest order, and these kinds of things. with regards to what will guide what will be consequences of actions besides their direct consequences, their eventual consequences. So that, the consequences of having ethics and morals is that to follow them is good. And then the consequences of having a theory of ethics and morals is that it's necessary to evaluate when the questions of ethics and morals arise, besides necessarily sometimes the right answer, the direct right answer, what is right and wrong, vis-a-vis why is it right and wrong. So as a technical philosopher, it's largely to be considered that what's right and wrong is according to that, and then what's right and wrong in interpersonal or human or global kinds of ethics and morals, this follows our common law. And since the founding of America and its independence and declaration as a constitutional democracy with established rights, individual rights for all, that's such a kind of thing as the questions of democracy and governance and participation in a social contract and these kinds of things are as well so related. So these are these kinds of things. So Sidgwick, he has this book, and so it'd be, I imagine we'd see references to Hume, Locke, and Mill, and all these kinds of things. The non-technical philosophy is that they're called philosophers. They're like so, pre-Socratic to post-Aristotelian, the pre-scholastic to the decay of medieval philosophy and transition to modern thought. And this is framed in terms of like this Englishman's view, but really then. It's much to be said about the center of science and thought that arose in the Middle East and during the period when in Europe is as rather the Dark Ages or the medieval times, that still the inheritors and who we inherit from, a lot of the concepts that still remain are is just this other part of the chapter, part of the history. Modern, chiefly English ethics, Hobbes, independent morality, psychological anti-egoism. Psychologism is the idea to ascribe kind of anthropomorphism, or to say that things that are technical or ethics or morals have also this psychological aspects to them, whether that's belief or whether that's disbelief or whether that's psychological certainty or psychological confusion. It varies. But it's not considered technical. It's just considered an exercise of an option of free will. When, for example, other means won't suffice to help establish what is right and wrong, or the what is real, or phantasmagorical or fantastical. Butler ethics, later intuition and common sense, utilitarianism, pragmatism, the empirical, all such things. The study of the ultimate good, ethics and psychology, free will. And he gets into Pythagoras, Democritus, Plato, Roman Stoicism with Seneca, Epictetus, and Marcus Aurelius. And then some of that gets into questions of might makes right, and these kinds of things. And the Christian and Jewish law of God, usually considered the Old Testament, and the vis-a-vis the New Testament, and what with regards to the usual foundation before common law of the common laws, vis-a-vis the power and might and history over time of people. Alienation from the world and flesh, the dissociation is an unfortunate condition, but at the same time, sometimes it's a coping mechanism. Forget about it. Christianity and wealth, you got your Franciscans and Benedictines kind of opposite sides of a coin. One sells salvation by charity, and the other sells salvation for money. You know, the Jesuits, ethics before Hobbes, ... Controversy between intuitional and utilitarian schools. Kant, Hegel, Schopenhauer. Kant and Hegel are very important for technical philosophy. Kant with being and Hegel with nothing. And Hegel particularly is right after it was like all this stuff came from the deity and the word is the word, you know. And then afterwards, everything after Compton and the scientists or scientism came kind of like to reject that whole other side. And so the problem is then it's just only polemical. But really it's that Hegel said, yes, we can even build a technical philosophy as from arising from a zero, a starting point, a nothing, and carry on. So that's where then with regards to then that the attachment there was made in philosophy to ethics and morals is kind of a big deal. But really that's just kind of the end of this book with regards to its influences. And Comte is mentioned, you know. So. Set Theory by Quine. Great little book. Set Theory by Quine starts, you know, it's in America. He's a Bostonian, so, but he speaks, he's very influenced with Briticisms and what. Readers already acquainted with set theory can quickly get further word on the aims of this book by turning to the preface. Meanwhile, I've been keeping this introduction intelligible, I believe, to readers in every likely walk of life. Even the reader who has only the modest knowledge of logical theory needed for pushing on in the book will already have known most of what I have thus far been saying about classes, but I wrote below this level for the sake of those who are not prepared to read the book, for they may as well know what it is that they are not pressing on with. Some of them might decide to read a little logic and come back. So classes and sets have the sets are the objects with only one relation with an element of. And so classes are the same thing, but when you define by a predicate or a relation something that would exist, and according to an ordinary or well-founded set theory, it can't exist because it would be paradoxical or an inconsistent multiplicity. You got a theory of classes. So a lot that is usually left out of logic, and it's too bad because then people get an incomplete picture, and it doesn't really end up in correspondence with De Morgan and the usual rules of the calculation given P's and Q's and their order and their negations. What are the results of causality, which is a key notion in the first principles and final cause that make for reason deterministically. So anyway, Quine has got a great book, and so the first half of it, he's like, first I write my own logic that's all ordinary and regular, thus according to the coherent, correspondent, pragmatic view of truth, it's indisputable. And then I go on to show how that carries on forward. Another related book that's very well known is Boulos and Jeffries' Computability and Logic. And so what they do similarly is start with notions after Turing, after Church, after Rice, and von Neumann and stuff like that in the early 20th century, and the theories of formal automata and computing. Then what it gets into is also the non-standard models of that. Like, what are the paradoxes and how it resolve that just via inference we arrive at these different things? How is deduction going to save us from having a theory that is wrong? Well, he doesn't quite arrive at that, but he does at least make it clear, and then in reaching out to Gödel's incompleteness and these notions that enable kind of like not being locked into a broken stubbed theory. It's in his 4th or 5th edition. You know, it's the text in that world. This is Suzanne Langer's Symbolic Logic, an introduction to symbolic logic. Excuse me. So in this 3rd revised edition, Suzanne Langer, and I've been reading some more of her books since I got this book, because I was very happy to read this book on logic, and that it's similarly to Quine, it both explains all the standard and explains its limits and explains what's not necessarily right with it and what in some contexts is wrong. So that is very well appreciated that, you know, out of Harvard, or I guess it would have been Radcliffe before it was co-ed, you know, then the author later develops a philosophy of art. And so, and then we get into the psychosocial and the perceptual, accorded that the philosophy is still the same overall study of these things and the theory of these things. That Langer's later works are very influential, and similarly with like Holm, who I started reading here earlier this year, and his notions of the three continuities, and then similarly for Descartes, and reason, perception, and the higher, the universals and particulars, and all these kinds of things. That it's to be said that later, as Langer gets into the art of poetry and the science of poetry and these kinds of things, and the perceptual things and symbology and stuff, like we read from Serlot, the Dictionary of Symbology, these kinds of things, that it starts first of all with a perfectly suitable description of logic in its well-known form in the mid-20th century and how it is. The appendix C is the construction and use of truth tables, which unfortunately has in about ways into the book, there's addressed material implication in what that means. And when you hear truth tables about the logical sequence and logical calculi, there's basically two entirely different ways of looking at it. Because one has material implication. If it's like, oh, if you have a false antecedent, then anything is true. The moon is made of green cheese, so the moon is made of green cheese. And similarly, if you have a false consequent, then anything that is the antecedent is true. Because otherwise, we always consider an antecedent to be causality or to be a condition that's so true, makes it like so. So what they call classical logic today is really Comte's, Boole's, Russell's, logical positivisms, not classical logic, because Aristotle will not be made a liar, and two elements that do not have causality or relation to each other say nothing about each other. That's about the entire problem of ex falso quod debate. When you reach a proof, then it's like, well, via this proof I was able to get a wrong step, and thus falling forward I proved anything wrong. It's like, no, that was error. Anything after that proved nothing, except that you can make errors. That, or from my perspective, that proved to me nothing except that I can make errors. One, we often will say one is like an impersonal first-person pronoun, instead of I or me or that kind of thing. So here, then it just kind of results that there are truth tables, for example, from the later schools of the 20th century called relevance logic, that are much more commonsensical than that. And you say ex falso nihilum, nothing. Out of fallacy basically comes nothing, instead of something that was supposed to be true, because that was just following a fallacy. It was just considered an error. So. But otherwise, this is entirely a pretty great book, and the author does go to some length to explain in the section where it's defined what are the limits and inapplicabilities of otherwise these rules of inference when forward inference fails, but especially to not follow forward inference that never really was there to exist with classical logic. Oh, that's interesting. What's this here? Philosophy in a New Key. Oh, this is more Langer. Yeah, I got some more study. A study in the symbolism of reason, right, and art. What is directly observable is only a sign. That's science. Science. What property must a picture have in order to represent its object? She quotes Wittgenstein or Wittgenstein. Most propositions and questions that have been written about philosophical matters are not false but senseless. Wittgenstein is a great rejecter of things, and it's strange because first he wrote a Tractatus Philosophicus, which is like rules that make for reason, and then he quite abandons it in his brown and blue books, and it leads into the whole notion of the nihilism and the existentialism, but it's a psychologism really. So Wittgenstein is our anti-Plato. He's held up in a very high regard, as that he's also a very strong Platonist to come around to it. In our deconstructive accounts that result structuralism, these kinds of things. The other day it was said that Descartes' main contribution to the world of thought was that everything breaks down into elements, and then you put it back together. That it comes back together. For monism and the whole of things. A proposition presents the existence and non-existence of atomic facts in a context. And in a way earlier talk, there was a talk about the apple in the universe. And everything else that is not it and it comprise one thing. So monism and that a continuum has individua and has parts are not necessarily distinct. They're distinguished to treat things elementarily, to treat things as via axiomatically, elementarily. That's fine. It's just not, closed. It does not condemn philosophical inquiry as such. It merely requires every philosophical problem to be recast. Problems of first cause and unity and substance. So here, this is again a great thing that a lot of the work in philosophy goes to detailing why free will is a matter of perception, and that it's a thing. So, which is fine. And for me, it goes without saying, it's unfalsifiable either way. So. Recently, there's been much news about the sky survey, cosmology, astronomy, and the theories of theoretical physics and experimental physics about the Big Bang theory. Father Lemaitre's theory from the early 20th century that basically established that there's an instant of creation in the universe, and maybe it was 13.6 billion years ago. And that from that sprang all things, and that was it's a good theory, and everybody knows it. And then there is also an alternative notion is the steady state hypothesis. It's eternal. It's existed forever. It will exist forever. So they've discovered that basically the greater sky survey, and as higher energy and configuration experiments come online, is like, well, all of inflationary cosmology was biased by its limited view, and that the whole notion that the inflationary cosmology is a real thing is not so. And then it's kind of explained that we live in a giant supercluster called the garden, or entelechiae, the garden of the stars, or something like that, which is billions and billions of galaxies, or it's large. So, anyways, both and neither of the Big Bang hypothesis and the steady state hypothesis are falsifiable according to science. And it goes well with that. Every few years is higher energy stuff came online, and the data so associated with it that the Big Bang hypothesis' estimate of the age of the universe grew every 5 years by about 100 million or billion years. It's called the running constants of theoretical and experimental and fundamental theories of physics, and it's a thing. So anyways, that's just to help explain that what's known as of a time that is believed is still held in high regard and kept as an example of what was there was good reasons to believe it. And so we make these what's called apologetics for the dogma and our canon and our theory of why they were thought right out of the time, and besides our deconstructive and critical accounts of why they're not correct or incomplete, these kinds of things. That so kind of works out that one is as a reasonably conscientious philosopher in the technical their conscience can very well be fully satisfied, which is good for the fields. Good for the fields. A tendency to organize the sensory field into groups and patterns of sense data to perceive forms rather than a flux of light impressions seems to be inherent in our receptor apparatus just as much as in the higher nervous centers with which we do arithmetic and logic. This one. So yeah, I was very happy to find this kind of school of things, the spirit of language. Goethe gives us pleasure. From Langer, the Music Teachers Association, basic unity of all the arts. Well, then that has to fall down. You can't have you can't necessarily have that. Although there's a theory of it. Artistic truth, so called, is the truth of a symbol to the forms of feeling. Well, that's going to vary, obviously, but some stuff is very clear on the face of it. So, vis-a-vis the lens and the cultural significance of the origins, Suzanne Langer is a pretty good theorist, and so far, I kind of feel like she fills that role. Here's this Hegel book I was looking for. I'm very glad I found it. So I was looking for this the other day, and it's here in the stack. And what's in it, and what's it about? What it's about is Hegel, and so this is Fritzman, and I've only barely begun to read this. He's an associate professor at Lewis and Clark College. He talks about G.W.F. Hegel, and but what he gets into, or he or she, why study Hegel? So far, philosophy has had only two heroic moments. First is Neoplatonism. Second is German idealism. So that's not necessarily true, because if those are those big moments, kind of like, the Bible starts with nothing in space, and then it starts in the middle, or the book of John it starts with a word. In the beginning there was a word. Those two events. But similarly, all our canon comes down from the Vedas and the Upanishads, and that which is prehistorical, like 6,000 years ago, the end of history before. To say that. Though there are these are the moments of technical philosophy that we have Platonism and an ideal universe, monism, and then Hegel is in idealism kind of come up with also the objective subjective also belongs to the thought and the thinkers, to us, as of discussion or relation or anything like that. So. Otherwise, the German idealists are just the inheritors of the tradition of the antiquarians that take what's good and provide apologetics, and as better stuff comes online, then they just dig up something that before was already there to help establish the priority of technical philosophy according to the canon and the dogma. And truth, back to truth and what it is. And so now I started to read this, and there's some pretty good quotes about basically the existentialism of Hegel, and he talks about Heraclitus and his monist dualism. Hegel's absolute. So this is again earlier in the conversation we were talking about that at the beginning of scientism, at the end of deistic dogmatism. There's Hegel, and he says we still get everything arising from this, whether it's void or whether it's universal, from the being and so on, which for Kant was a little tentative in that. It's like, I'll give you the sublime and say that the sublime is bigger than us. Well, it's a thing and it's an ideal. Then Hegel's like, I'll take the other side and say nothing's the same way. And then we have kind of the logical positivists are basically axiomatic empiricists. It's pragmatic, it's just not complete. And the theory can work into why continuum and these other things make it so just reasons that were made for why things are very simple to calculate and compute are not really necessarily the most truthful things that needed to have an overall truth. And that scientism and logical positivism are kind of a psychologism. So anyways, yeah, I'm glad I found this book because I was looking for it. So Descartes arrived at, I think, therefore I exist. Cogito ergo sum. Although I have described this as though it were an argument, and therefore ergo suggests this, Descartes denied that cogito ergo sum is an argument and instead insisted that it is an immediate insight. This is like the book of Zen. I got this book of Zen the other day, and it's like you can't, nobody can tell you what Zen is, it tells me. You have to experience it. So Zen basically is the idea of like, we perceive time in its forward progression of time. But what if it's just starting and stopping all the time? So it's kind of like waking up and you have amnesia and went back in time. Is it the same? Yeah, maybe not. This is Gadamer, and so again, I was going to start reading about Rise Over Run and talking about Rise Over Run, but it's really getting into some of the preliminaries that arrive at kind of like why is there something rather than nothing, and for that there's these other talks I kind of been working on. I'm calling that philosophical foreground. So maybe this would be better placed in that or something, but. Philosophical foreground is this idea that these ideals are enduring, and you can't really know them. You have to experience them, and you can't really experience them. You have to learn them. Both. So, but either way, everyone does perfectly their own way how they do that. Automatically, it just is existence and being. It's natural, very natural existence. Say. So Gadamer starts up and he says, okay, so we got Plato, Socrates, Plato, and Aristotle kind of in a row. And so the usual course of development is to study them kind of in their order and their evolution. And he says, we can't really see things how they saw them because we have a different lens, and And so similarly, it applies the same. So anyways, these the dialogues on the dialectic of Gadamer, who is a student of Heidegger, and amicus Plato, we're Platonists. And usually that follows like, we're Platonists, but ... something else. But Gadamer just stands, it's like we're Platonists. After the criticism, after the development, after the dialectic, after the dialogue. So, big fan of Plato and Heraclitus and the canon. It's our canon. All right, now here's differential geometry. So this is, of course, one of the books that was started. It's funny, it's faded a little bit here in the sun over the summer about these submersions and sheave. This is a subfield of differential analysis, differential geometry. So kind of like the algebraic geometry is at least two fields: algebraic geometry and algebra geometrically. It has this differential geometry, and its submersions and immersions are basically like when you think of modern calculus today and the standard, and it's like the linear asymptote, an infinite line, is not differentiable and doesn't exist, and so it's a discontinuity. Then this just says, and neither is a flat line either. But as long as we can keep things really in the middle, then we have all these things that have closed forms, they're finite, and they work great. Well, sure, that's great. So back into symmetries, submersions, and sheaves for this descriptive differential dynamics, is that I have much to learn of that. So let's take a look at here and see, kind of get into vector, dot product, Gauss map. Yeah, there's Gauss for you. Let me pick a principal branch for you, and follow that, right? Surfaces with minimal surface area. So he mentions the soap film, so that speaks to Courant, Courant and Robbins and their studies of these things. And algebraic geometry, and with Lefshetz and Picard, and that's something I really want to learn vis-a-vis the Bourbaki and the algebraists of the other side of the school. A surface with k equals 0, which is not a ruled surface. So it reminds of the regulus, which is like, it's a 3D surface, but it's made by only straight lines. Like any point on it is like a member of a straight line that goes through all the things. So like it couldn't be just, it couldn't be something with bumps and knobs all over it, because at some point in time those would have a cusp, you know. But it could be like just like a fold piece of paper, because that's just all the lines. They fold a plane, and similarly, any way you could fold a piece of paper, it's regulus until it's deformed. So it's a planar. And this is in the projection and perspective, that we think of geometry as points and lines to spaces, but then there's also an important way to start to think about it as projection and perspective, as with fixed projections and fixed perspectives. So and that gets into also what's called the fixed point theorem, which is the point in infinity exists in perspective. You know, it's the point at infinity, and everything, it happens to be a very dense point at infinity. It's a journey. Profile curves on the surface of revolution. Analyticity, that U onto R cubed be a minimal surface element without level points. So it's simple. Then there's a parameterization with the property that three component functions are real analytic. Members of C inf D, C are written C omega, hence locally developable in a Taylor series, or otherwise any other means of developing numerical methods that arrive at y. You can develop an infinite series representation of a form, and that the first few elements start to get very close, and then over time there's results that it arrives at that it's no different. So that's something, and this field is about finding these sorts of methods, and then they make things tractable by setting them up this way. So this is a good book, and it was kind of been here for the time, and so we'll set that back up there. And similarly, this is then the methods of symmetries. Similarity variables, arbitrary functions, heat conduction, only for those solutions for which ... and its consequences ... hold. Symmetries are included here as those conditional symmetries for which Formula 1851 is true, that a particular product of an item in its power series without making use of ... and its consequences. Oh, that a difference formula instead, and that is set to zero. That both these equations set to zero. One is a product, and the other is a sum. From the computational point of view, the main difference between symmetries and conditional symmetries is that when h sub a equals 0 has been properly used, the equations x h sub a equals 0 are identities in all remaining variables in the case of symmetries. So here, this is just another way to show that similar to differential geometry and finding about how the first few terms can be set up. It's for numerical methods, and then it's pretty great. And it goes back to this whole conversation about Mulligan's nonlinear FX and applications, and the development of rank lowering terms and various methods, and the grab bag toolkit, whatever works to find the solutions of these things. That here, it's just kind of in the section on partial differential equations and how to use Lie point symmetries, that Stefani has really helped to kind of isolate that as a fundamental theorem. That a fundamental theorem is something that makes it so that then you can use that to it's reflected and compounded in many, many different aspects of the treatment of the objects under analysis. It's fundamental. And that then when we have a fundamental theorem of, for example, sets in a set theory, or a fundamental theorem of classes in a class theory, that it helps to treat them elementarily by their differences as well. Here it's just establishing that when we have a particular quantities that are kind of like Tissot by one means that we can box it and frame it, then another means we can get the projective out, the perspective, and so we can kind of know that it's a square. Then we can treat it as a square, and that's in the descriptive. That's all my view that I have of it, in terms of that it would apply then, and this other stuff that can come out of this. In developments and their derivations, Here the derivative in derivations and mathematical proofs means any kind of inference in a mathematical proof. You got definitions and derivations, and that the derivative here, though, is a particular abstract of lowering the rank of a formula, kind of in these integral and differentiable operators for functions, and that the objects of this treatment are functions, function theory for topology, that the objects of the statements and the derivations and the manipulations of terms and the systems of equations and the systems of inequalities and the systems of relations are a thing. And then that all these means of the continuous of them is that there's always a relation among the things. Then quantifying things is a very strong statement, in effect, for those. Separability of PDEs. Symmetries in the language of forms. Oh, all right then. Differential forms. So forms get into operator calculus, and forms are great. Differential forms offer an alternative, more modern way of formulating systems of ordinary or partial differential equations and of getting insight into the structure of their point and context symmetries. Here I would reflect on the notions from the singularity theory and the multiplicity theory and the inner and outer products and a geometry of points and spaces vis-a-vis points in their next element lines, the entirely opposite milieu points and spaces. Then for these point and context symmetries, where we can start to find the corner of the page, where it is and figure out these kinds of things. The basic objects we have to deal with are vectors and forms denoted by small bold-faced Greek letters such as sigma or omega, which exist in an n-dimensional differential manifold. Coordinates space, it's Euclidean essentially. So one form, a Pfaffian. Oh, these are the Pfaffians, P-F-A-F-F, Pfaff. So the Pfaffians get into a general introduction to the operator calculus is kind of how I feel about them. Interior product, exterior product. Wedge. Most general two form. Linear superposition of the n-choose two forms. dx alpha wedge dx beta. That's nice. So these become just diagrams and drawings. And then you can, and just like algebra, you can kind of cancel above and below in the numerator like terms and orders, ordering and rank reduction and the addition formulas and the identities they have about those. It's the same kind of idea here to reach up to those in these systems, to then be able to frame something in terms of a system and treat it systematically vis-a-vis elementarily. So let's see what else is going on. Differential equations in the language of forms. To write a given differential equation or system of differential equations in the language of forms, the typical strategy is as follows. So here I'll just read from the author here. First one writes the differential equations as a set of quasi-linear first-order differential equations by introducing the necessary number of first, second, and so on derivatives as additional variables, additional to the originally given independent variables. So this is framing it out in a space. Okay. This will be possible only if the original differential equation is linear in the highest derivatives. So it's kind of treating it as a rank lowering or system to reduce the rank ordering to a system that's more tractable in a lower rank ordering, I imagine. Or here that is using a reflection principle or symmetry principle to get that same effect the other way and figure out a way to flatten it out and find its line. In this enlarged set of variables, the above-mentioned system of quasi-linear first-order differential equations essentially says that not all of these variables are independent of each other, and that therefore linear relations between their differentials will exist. Linear independence is a key notion of the vector theory, the linear algebra, the treatment of objects as vectors algebraically, but geometry has circles. So Is this so? Yeah, quite linearly and standardly. Yes, it's so. Relations can be written in terms of forms. A second step, we must find a set of forms such that finding an identity to zero, so then you can kind of find a way to neglect, to discard the things, and as what remains having a well-known analytical character in an area that it's fair to say, it's proven to show that it's well defined. And then from this, one recovers the original differential equation as well as the relations that ensure that some of the variables are in fact derivatives of the others. Oh, that's kind of nice. So, because those are the values is so evaluated. So we got the definite and the indefinite integral, and so the indefinite integral is a function, and the definite integral is evaluated for some bounds. So he's finding some of these definite bits, then to employ the great utility of the dot product and eigensystems to find stuff. See how this procedure works. Well, that's something great, and I relate that to my incomplete and only partial study of what are forms, algebraic forms, simplicial varieties, redifferent integral systems, and that. With this particular development coming from a state of this quasi-linear PDE systems. That the more words, the you know that all fit together make for that science is a great cabal of all the words together, and it's great. It's true. This is what it is. Law, analogous law. To evaluate the rest of the symmetry conditions arising from the Lie derivatives for the heat conduction equation is a more difficult task. It turns out, however, that no genuine context symmetries exist. Not clear. And that the Lie point symmetries are exactly those given. Well, I mean, that makes for an entire fundamental treatment of this. Is we really gotten most depth so far in this talks about Velasquez's book on heat conduction, the Fourier series, Fourier style analysis, and a lot went into what are the edges and the corners where the cases are multiplicities, not singularities. So that's then it gets into Lie Bockland. So Beckland or Bockland, B-A umlaut C-K, Lie Bockland, and how to find them. It starts with pretty much this form setup we talked about. Two set of differential equations, and vis-a-vis that was the formula, the HA ... That the result will in general be a different set of differential equations, which moreover will be of different, possibly even infinite order. See, then now what I want to use this Lie Bockland symmetries is for my stop derivative setup. That goes either way, basically, to figure out how for like the linear impulse, force equals mass times acceleration, vis-a-vis that's the notion of like a perfectly inelastic collision and or like Newton's cradle, that the device that just swings back and forth like a pendulum, where the bearings strike on one side and the other ones fly off on the other side, leaving the one in the middle motionless. That I'll look for this because it would be it framed in one of these kinds of things, that on the one side is this linear impulse in the finite many terms, and the other is the infinitely many order dimensional, with those as vanishing, coming down the same thing. Here for the back to the ideas of the identity dimension and the hyperbola, as particular about the inverse hat analysis after the Fourier style analysis that's being built up. These notions after projection and perspective, a bit more of a whole analysis type of thing. All right, so and then here is the path integral formulations. And then the other thing that started this whole descriptive differential dynamics in that symmetry, submersions, and sheaves was for the differential topology. Because in this book, the author, Charles Nash, he starts and he describes a breakdown of differentiation to the pseudo-differential. And so that's a very key thing to start figuring out what happens when it is for something like Poincaré's rough plane or these other kinds of notions that we've been addressing, that it's topologies. That function theory and topology are the only thing that are really allowed to move in these theories in the development derivation vis-a-vis the objects of the elements of set theory, the objects of the elements of part theory, the objects of the elements of categories and types separately each, the objects of the elements of arithmetic, and even breaking down arithmetic into at least two operations, the objects of the elements of algebra, and similarly about like the higher order and the first order, all about the zeroth order, that goes on this little stack right here. And then there's jet bundles and Descartes and all this kind of stuff, and some reason that meaning, truth, and God is like about apologetics for why, what lessons learned, or as for truth settings of truth, and also for ethics and morals, why that is about meaning, and the perception and meaning, and what each person has of their own, that. And here's path integrals and quantum processes. So the desk hasn't much changed yet. And he talks about gauge invariance and gauge fixing and this and that, which is for putting quantum mechanics and relativity together, as discussed. Ehrenfest's theorem, functional chain rule. That was nice. As a result, higher order functional derivatives generate higher order time ordered products. So that will get into this whole development, of the path integral and the propagation equations, and this and that. For here, all I've figured out in all these talks is how to describe what would be this the stop derivative or derivative stopping, and those being these kind of complementary concepts of these pre-Cartesian identity dimension in only the positive numbers, and then helping to explain how that in accords with all the rest of mathematics is a real thing, and then it speaks for these differential symmetry, submersions, and sheaves. Then as vis-a-vis the pseudo-differential, the pseudo-momentum, about the instantaneous rate of change, about the weight of change, the weight of the state, or the momentum, pseudo-differential, the pseudo-momentum, and some rest part, that have that. This is a large part of an entire milieu of differential systems, which for Einstein is like, the whole thing must be a differential system. So this was my theory, and dynamical modeling, and this kind of thing is about the theories of things and about the great strengths of the theories we have and the limits. So this was like the energia and entelechiae, the energy and the completion of things, as quantities and substances, the ancient terms. This is this is just kind of development as today, and so what I've kind of drawn for this development is that out of the symmetry, submersions, and sheaves for function theory and topology are still coming a great amount of elementary primitives to help define what are the inverse of these infinite dimensional and zero dimensional, all from the same theory as there is entirely. Well, have a great day. I hope this isn't too long or run short, and happy New Year, if not by the end of the year or something like that. It's been a long year, but it sure has flown past. So long.